Dear students, in this topic, we are going to learn about fuzzy inference system. So before going into the PPT, I want to tell you something related to this. So please listen. So what we are going to do. So what is fuzzy inference system? So what is meant by inference system? Basically, I want to take one example like what are inferences? Suppose we have seen what are the inference rules and how we are going to summarize them or calculate the conclusion or derive the conclusion. Now, suppose I feel that, for example, my preparation for an exam, for your exam preparation, if preparation is well, okay, so you will say that your results will be good. Okay, so results are good. So don't blame OU. Okay. Second one, uh, some people will feel that if you are good, you can work well. No issue. Some will say that if I have money, I will be happy. So money does not give everything, but some people feeling is that. And if I am healthy, okay, I'll work hard. So all these things, some conclusions. I'm just writing the conclusions. Now, we are a human beings. By birth, I have this particular basic intelligence. So I call it as intelligence. It's not like intelligence, like what we can conclude. But coming to the artificial intelligence, this it cannot do because it is not an human brain. So it cannot do. So what we are going to design now, I will design one inference system. Okay, where if this is happens, this will happen. Okay, for example, if you have money, you will be happy. So, what are the consequences or what are the logical reasons? Okay, you have to mention for this. So, these all comes under your fuzzy inference system. So, how this particular fuzzy inference system can be designed with the help of the fuzzy logic? What are the components of the fuzzy inference system? So according to the fuzzy inference system, you can make the decisions. So this we are going to see in this PPTs or in this lecture. Done. So fuzzy rule-based system, fuzzy models, fuzzy expert system are also called as inference systems. So whatever the rule base you are going to write or whatever the, okay, so whatever the models you are designing, okay, so whatever the, change the colors. So whatever the logic system I am going to build. So all this comes under your fuzzy inference system. Okay. So this is what I told how you to design one inference system for us. Okay. Now, always the fuzzy inference system by the name itself, inference implies if else, okay, if then rules, okay. If I'm writing one if statement, then will be there. If I'm happy, I'll be working well. If I'm preparing well, I'll write exams clearly. If I have money, I'll be happy. Or you can go with the connectors. I'll add two connectors. I have money and spending well, so I will enjoy. If I'm preparing well and writing exams well, then I'll get the results. So all these things will be combined in order to frame the rules. Okay. And coming to the input may be fuzzy or crisp. See, remember here, I'm not telling that input is only fuzzy. So I can have the crisp input also, where I can convert into fuzzified input and I can do the process. So we'll see all the components, what are the available here. So what I'll do, I'll take the input, I'll go for the inference system, then I'll make the decision. Okay. So in order to convert your fuzzy input to your like crisp, fuzzy input output to the crisp, you have to go for the defuzzification. Or if you want to convert crisp to fuzzy, you have to go for the fuzzifications. Already we know that. Okay. Now, what are the basic inference system consist of? So in this, if you see, 1 second. Yeah. So first we have a rule base. You'll have the all set of rules. This is called as the rule base. Second, you have the database where you have all the membership function of the fuzzy cells. Third one is decision making unit, which will perform all the operations. So we have seen in the previous rules how to conclude. We will use ZA rule, max-min rule, or we can go for any other rules in order to get the conclusion. Then what is fuzzification? Converting the crisp to fuzzy. Defuzzification is for converting the fuzzy to crisp. Okay. So these are all available in the fuzzy inference system. So once again, I'm just briefing. You'll have the fuzzy rule-based set of rules, database for the membership functions, a decision-making unit for operations, fuzzification for converting crisp to fuzzy, and defuzzification for converting fuzzy to crisp. Now, so if you see the diagram, same. So I can take the input. Okay, I can take any input over here. I can take crisp or fuzzy input. If it is a crisp, I have to convert into fuzzy to a crisp to fuzzy. Then I'll go for the, in order to convert this, I should have all the membership values. So it will have the database and rule base. And after this particular input is shared to the decision making system, again, the output will be fuzzy. If the output is fuzzy, we cannot understand what is the decision. So what I have to do, again, I have to convert into defuzzification. So this is the overall structure of a fuzzy inference system. Okay, so you can use any input methodology, like you can go for the crisp input or fuzzy input. So same what I have explained, working of the methodology FIS is first we will convert crisp to fuzzy input, then we'll go for the fuzzification, rule base, and then you'll do the operations. Finally, you'll do the defuzzification in order to get the crisp output. So in order to make the decisions. So it is a simple example, rule base. You'll have the fuzzification. You'll give the input output as x1 to x2, xn, and this will be here. In order to get the database, you'll have the membership function for inferences, rule base for inferencing. Fuzzification, you'll use the membership functions. Finally, you'll have this output in the form of the fuzzified output that have to be defuzzified. Okay, so this is the inference system. So what are the different fuzzy elements we are going to see? So as we have seen in the diagram, input vector, which is in the form of x1, x2, x3, so on xn, output vector, fuzzification. What is meant by fuzzification? Converting all these values into crisp values into fuzzified values. Then rule base, you'll have all the if then rules. Membership functions, whatever the type of membership function you want to use. Inferencing, it will have all the rules and decision processing, and finally defuzzification. Okay, so just 1 minute. So what exactly we are doing in this one? I just want to explain you here. So what you are going to do here? First, I'll have the input. Okay, input may be both crisp or fuzzy. Okay, so first it will enter into the fuzzification. Okay, fuzzification module, where the crisp will be converted into fuzzified output. Okay, if it is fuzzy, no need of this module, directly comes here. Then I'll have here inference system. So inference, here I'll get the conclusion. Okay, whatever the result. Okay, conclusion. This conclusion, but this will be in the fuzzified. But the user cannot understand. So again, it have to be converted to crisp. So what I'm doing here, so for that defuzzification. So this defuzzification will convert your crisp value, fuzzy value into crisp. Okay, so this is the exact process which we have seen in the slides. Okay. Now, so what we are going to do here? Okay, so we have two types of methods over here. First one is Mamdani FIS and second one is Sugeno FIS. So these methods are different types of methods. So each will use their own strategies in order to do the complete fuzzy inference system. First, we'll start with the Mamdani. So this Mamdani was proposed by Ibsahim Mamdani in 1975 for the control system of a steam engine and boiler combination with the synthesizing a set of fuzzy rules. So in order to control a steam engine and a boiler, which is a combination, with the help of this particular guy, it have been automated. So the output membership functions are expected to be fuzzy set. So here they want only output in the form of fuzzy set. So what exactly have done? First one, determine set of a fuzzy rules. For anything, the fuzzy rules will change. If you're talking about AC, okay, if I want to automate the AC, so what I have to do, I want to convert complete set of inferences. I have to mention the rules. How we are going to mention the rules over here is, for example, whenever the temperature is 40, I have to on the AC. So it will check the temperature. If temperature equal to 40 on the AC. So here your predicate is if temperature is 40, your conclusion is on the AC. Like that, you have to determine all the set of fuzzy rules and then make the input fuzzification according to the input fuzzy, according to the membership functions. Then combine all these fuzzified input in order to make the rules. Okay, determine the consequent rule. For this particular rule, what is the conclusion and what will be the output. Then after that, see here we are using decomposition. So first you are individually calculating the conclusions, then we are combining. So decomposition and aggregation we are using. So combine all the consequence to get the output, that is your aggregation. Finally, your defuzzified output distribution is obtained. Okay, so this is a method used in Mamdani FIS. So what are the basic thing? We are computing the complete rule strength with the help of fuzzified inputs from the fuzzy combination, and output will be the rule strength. So the output of all the fuzzy rules can be combined in order to get one fuzzified output. And in order to get the common defuzzification values, you can use any mean of max or center of mass methods. The next method is, okay, this is related to this one, Mamdani. So you are identifying the set of rules, you are getting the input, you are doing the defuzzification, fuzzification, then you are combining all the individual set of rules output with the help of the aggregation. Finally, you are converting the fuzzified output into defuzzified output in order to know the conclusion. So this is the whole process. Now coming to the Sugino model, it was developed by Takagi Sugino and Kang in the year of 1985. So these rules are basically based on the if X is Y and Y is P. So there also you will have the rules of if then. So here basically these are based on your if then rules. So here generally all the f of x comma y we are using as a polynomial, and what we are doing, all the first order polynomials we are using, and we'll get the first order Sugino fuzzy model, and if f is constant we get zero order. Okay, if f is constant we'll get the zero order, otherwise we'll get the first order polynomials. And based on this Sugino model, what we are doing, we'll take all the polynomials, first we'll fuzzify, then apply the fuzzy operator, what are exactly the same what we are using. And the basic difference is the membership functions. So there we can use Sugino models is that membership functions are either linear or constant in case of the Sugino. So here the membership functions will be always linear. So remember this point. So if X is, this is your linear equation. Sugino will use all the linear or constant membership functions, where Mamdani uses any type of functions, membership functions. So if you see here, so input 1, input 2, what I'm doing, input the membership functions, all that, and finally you are getting the output according to this particular rule strength, and we are getting the output membership functions using the linear equation. Now, the comparison between Mamdani and Sugino is, first one, Sugino output membership functions are linear or constant. And the basic difference is fuzzy rules and set of their aggregation rules, which are used to different according to the requirement. So in the Mamdani, we can use any type of inference rules, but in the Sugino, we have to you act according to the polynomials, because we are using only the polynomials. Okay. So a large number of fuzzy rules must be employed in Sugino, whereas compared to this Mamdani, and the configuration of Sugino is smaller than the Mamdani. Okay, if non-triangular trapezoidal is used. So triangular or non-trapezoidal rules are getting in your Mamdani, it will be easy. But coming to the Sugino, it will be a little bit difficult. So what are the advantages of Mamdani? It is widespread acceptance, suitable for human input, and it is intuitive. Okay. Now, advantages, it is computationally efficient, but it only suited for mathematical analysis, not for other set of rules. And it is guarantee continuity of the output surface. Means we are going for the linear. So it will be work according to the continuity. Okay. So finally, these are the two FIS methods which we are going to use in the fuzzy interface inference system. Thank you.